Hey guys, welcome. I've already made a video proving the binomial theorem here at the top left, also known as the binomial expansion formula. So check out that proof video. But in this video and at least a couple more, I'm going to give you some practice problems, some fun practice problems, I might add. And although the two problems in this video I've called basic examples, in most classrooms they'd actually be considered advanced examples, but I think they're like a straightforward application of the binomial theorem. But yeah, they're fun, so let's get started. All right, so the first one is this, which is we take this binomial to the fifth power and this binomial to the fifth power and find their difference, and we are to write that difference in the form a root 7, where a is an integer. So it's clear that the binomial expansion formula or the binomial theorem will come in handy when we're expanding this binomial here and this binomial here. It's also clear that what we need is x plus y to the fifth power. So basically this formula where n is 5, right? Okay, cool. And so then that would look like this. X plus y to the fifth power, according to this binomial expansion formula, will be this right-hand side, which spills onto the next line. Now, we know that 5 choose 0 is 1, and 5 choose 1 is 5, and so on. So if we do that simplifying, then we could write it in this way. And so x plus y to the fifth simplified will look like this. And looking at this here, the binomial x plus root 7 all to the fifth power, it's pretty clear that comparing it to this guy, x is 1, and then y is root 7. So basically, we could just use this right-hand side where x is 1, we replace all the x's with 1, and we replace all the y's with root 7, right? And so doing that, we could write this here. Now, this could be simplified a little bit more. For example, in this third term, 10 times 1 cubed is just 10, and then root 7 squared is just 7. So this is just 10 times 7. And here in the fourth term, we've got 10 times 1 squared is 10, and then root 7 cubed is root 7 squared times root 7, so that's 7 root 7. So in total, we have 10 times 7 root 7. So doing that kind of simplifying, we can write the following. And this here can be simplified even more, which is that like here, 10 times 7 is 70, and 10 times 7 root 7 is 70 root 7. But this here, 5 times 49, I'm just going to leave as 5 times 49. You'll see why. So basically, we're going to say that this next line is the most simplified we can get this guy, which is the binomial x plus root 7 all to the fifth power. So here is in its expanded and simplified final form. All right, so then let's pay attention to this other guy, right? And comparing this other guy to this x plus y all to the fifth power, we see that x is again 1, but y is negative root 7, because we can write 1 minus root 7 as 1 plus negative root 7. Yeah? So all we have to do is on the right-hand side here, replace all the x's with 1 and all the y's with negative root 7. And when we do that, we can write this here. And 3 of the terms are going to be negative, and that's because they have a negative number to an odd power. The first of those is the second term, where we'll have to write 5x to the fourth y, but x is 1 and y is negative root 7. So this here is going to be negative. Specifically, it's going to be negative 5 root 7, right? And this guy, however, is going to be positive because negative root 7 squared is just 7, right? Whereas this guy is going to be negative like this second term, right? This fourth term is going to be negative because we've got negative root 7 cubed, and that's going to be negative 7 root 7, this part, right? All right, so then the highlighted guys, the 3 highlighted guys are going to be negative, as I just explained, but everything else is going to be positive, and so the next line is a simplified version of the previous line. So this here, right? And we took care of things like this guy being negative 5 root 7, and then took care of things like this guy being 10 times 7 and stuff like that, right? And in our final step, right, like we're going to figure out that 10 times 7 is 70. So basically, same kind of simplifying as we did and going from this step to this step, we're going to do again and going from this step to the next step. But otherwise, as we did earlier, we're going to leave 5 times 49 alone, and you'll see why. And now we've got this guy all figured out, expanded and simplified, and we've got this guy all figured out, expanded and simplified. So we're ready to take the difference between them, and let's line them up. So if we line them up, this guy is this guy, and then the second line is this guy, and so we subtract. 1 minus 1 is 0, but 5 root 7 minus negative 5 root 7 is 5 root 7 plus 5 root 7, so 10 root 7, and similarly these guys combine to 140 root 7. Remember, we're subtracting, and then these guys subtract out, and these guys combine to 98 root 7. If we look at all the survivors, they all contain root 7, so we're going to be able to write our final answer in the form a root 7. Specifically, a is going to be 248, and so yeah, our final answer is 248 root 7. All right, that's it for this first basic example. So let's move on to our second one, which is just as fun but much shorter. All right, so that's this here. Here we're asked to evaluate this sum. Well, the n choose 0, n choose 1 are like the n choose r's, so those are recognizable, and we know that this has got to do with the binomial expansion formula. But what happened to the x's and y's? Well, if instead of x and y we use a and b, then a plus b to the n is going to be basically this here, where x is replaced by a and y is replaced by b, and interpreting sigma, right, we can write this here, right? Basically what I'm saying is this here is what the binomial expansion formula would tell us we'd have to write for a plus b to the n, the right hand side, right? Now comparing this right hand side to this, we have the n choose 0, the n choose 1, the n choose 2, the n choose n. What we don't have are the a's and b's. So we think a little bit and see that both a and b must be 1, because if in this right hand side we replace all the a's and b's with 1, then this here would turn into exactly what we have to evaluate. So that's it, guys. If we let a and b equal 1, then this here would turn into n choose 0 plus n choose 1 plus n choose 2 plus ... n choose n, and therefore what we have to evaluate is 1 plus 1 all to the nth power. In other words, 2 to the n. Yeah? All right, cool. So I hope you enjoyed the 2 basic examples, and equally interesting examples to come in 2 more videos, the skilled examples and the expert examples. All right, keep watching. Take care.